Open loop control system. So a system in which the controller action is independent of its output. That type of system can be called as open loop control system. So I am taking a simple open loop control system here. This is the controller and this is the system, and we are having output here, and this is our reference input. So a system is said to be open loop control system when the controller action is independent of its output. The controller action is independent of its output. The type of systems can be called as open loop control systems. Independent of the controller action is independent of its output. The type of system can be called as open loop control systems. So examples for this open loop control systems are traffic lights, traffic lights, fan, microwave oven like that, etc. So we will be setting some time limit for the traffic light. So irrespective of the traffic density, the traffic lights will be glown. So that is the controller action is independent of its output. So if the junction is like this, if one side the traffic density is more and another side the traffic density is less. So irrespective of this output, so here the traffic lights will be glown based upon the time limit, time set. So here the controller action is the traffic lights. So irrespective of the output, the controller action will be uh, working. So this type of systems can be called as open loop control systems. So fan also another example, because irrespective of the ambient temperature, fan will be rotated and it will be depending upon its regulator. So regulator set, that is one kind of open loop control system. And what are the features of this open loop control systems means? The features are, in open loop control system, the output has no effect on the controller action. This is the first point. The output has no effect on its controller action. The output has no effect on the controller action. On the controller action. The output has no effect on the controller action. So hence the output is neither measured or nor fed back to the input for the comparison purpose. So we are not taking the output for the feedback, and we are not measuring the output, and we are not giving the feedback to the input for the comparison. This is the first feature of the open loop control system. First one is the output has no effect on the controller action. So irrespective of the output, the controller action will be functioning. And for the system, the output remains constant as long as the input is constant, provided that the external conditions are unaltered. The output may be constant as long as the input is constant. So until we change the input, the output will not change, provided that the external conditions are unaltered. That means all the remaining conditions are keeping as same. As long as the input is constant, the output will also be constant. There is no change in the output depending upon the output ambience or something whatever it may be. The third one is faithfulness of the output. The faithfulness of its output is depending upon the calibration accuracy. Faithfulness of its output depending upon the calibration of controller, depending upon accuracy of the calibration, depending upon accuracy of the calibration. So here we are setting the time for traffic lights. So here how you are setting, that is the accuracy needed when you are calibrating certain things. So here the output, the faithfulness of the output is depending upon the accuracy of the calibration. And output can be changed by varying the input manually. That's why this can be called as manual control system also. Output can be changed, output can be changed by varying the input manually, by varying the input manually. That is the another feature. That's why these can be called as a manual control system. So there are four features. First one is the output has no effect on the controller action, and the output will be constant as long as the input is constant, provided that the external conditions are unaltered. Faithfulness of the output is depending upon the accuracy of the calibration, and output can be changed by varying the input manually. And these are the features of this open loop control system and advantages of this open loop control system. Advantages of open loop control system are it is very simple to design and because less complexity in the circuit, simple to design and easy to maintain. Complication is not there in the circuit design, that's why it is very simple to design and easy to maintain. And these are economic also. These systems are economic due to low cost to design. So due to low cost to design and maintenance, to design and as well as maintenance. These systems are easy to operate. Anybody can operate because there is no complications in the circuit design and also easy to operate. So generally these systems are not toppled due to stability problem. So you can say these systems are more stable, not suffered due to stability problem. So these are the advantages of open loop control systems. There are disadvantages also. Disadvantages. These are inaccurate as the output neither measured nor fed back to the input for the comparison. So these are inaccurate. So you need to have recalibration. You need to have recalibration for the change of the output. Recalibration of input for the change in the output. Recalibration of input is required to change the output. So this is another drawback. Every time you need to recalibrate the controller for changing the output. So changes in the output does not corrected automatically due to some external disturbances. So you will be getting incorrect or inaccurate results due to parameter variations. Inaccurate results will be obtained. Inaccurate results are obtained due to parameter variations. Parameter variations. So these are the drawbacks of open loop control systems. Advantages are simple to design, easy to maintain, economic due to low cost to design, and also maintenance is also less, so easy to operate, more stable systems. And disadvantages are inaccurate and recalibration is required for change of output and inaccurate results are obtained due to parameter variation.